welcome you to the 54th lecture of NPTEL online certification course Drilling and Blasting Technology. We are continuing with our special blasting techniques. This is the fourth topic of special blasting technique, where we are discussing about the blasting of boulders. In the previous lecture, we have already started this blasting of boulders. First lecture is taken. This is the second and final lecture on blasting of boulders. But as we do, let us retrospect what we have covered so far. So far, we have covered the basics of drilling and blasting. We have covered the understanding explosives. We have covered explosive and rock interaction. We have already carried out the design procedures of surface bench blasting and underground blasting. We know what are the key performance indicators of a blast and drill parameters. We know how to calculate, how to identify those parameters, how to calculate the cost analysis for drilling and blasting operations, and we have understood the impact of rock and rock mass properties on the blasting performance. And currently, we are discussing about the special blasting techniques. In this special blasting techniques, this is the fourth topic we are discussing, that is the boulder blasting techniques. In our previous lecture, we have covered the types of boulders, where these boulders are coming from, how these boulders are generated, how that has to be handled. So, we have found there are many methods to blast the boulders. Among that, we have already discussed the pop shooting is already discussed. So, in this currently we are going to discuss about the rest of the part, rest of the boulder blasting techniques. So, our next topic is plaster shooting. We have seen in pop shooting, we had a big disadvantage that we had to keep one small diameter drill machine for carrying out drilling inside the boulder. So, that is very difficult. The drilling operation itself is costly, drill management is also very difficult. So, for these boulders you have to bring the compressor, you have to bring the drill machine. So, that is very difficult one. To overcome this process, the method which is found is called plaster shooting. Plaster shooting is a method where, suppose this is the boulder. So, one has to keep an explosive above the boulder, means without drilling, only on the wall of the boulder or on the surface of the boulder the explosive will be kept, and that explosive will be covered by a clay or cement. So, it is basically you plaster the explosive on the wall of the boulder, either using a clay or using the cement, and then detonate the explosive. So, it is explosive, detonator, then the other accessories which are required. So, this explosive and accessory system that is placed. So, explosive is mainly placed at this surface of the boulder, so that the way similarly the waves are propagate and fragment the rock, the same way it will do, but there is a loss of explosive in this direction also. So, that is why this plaster shooting is one technique where one can blast the boulder using the explosive, but it is understood, if you are carrying out the pop shooting, the explosive is inside the boulder, that means fully utilization of the explosive energy is carried out there, but as here the explosive is placed on the surface of the boulder as the outside material, the most of the explosive energy is dispersed in the atmospheric or air medium. A small part of the explosive energy is only utilized in the fragmenting the boulder. So, that is why the explosive energy is not fully utilized here, and there is no, basically this small clay or cementing confinement is given, is absolutely very poor confinement we are basically providing to the explosive. So, that is why this method is called plaster shooting. Plaster shooting was given example in 1978. So, it was reported to be used from long back, and it is found that the loading factor is ranging from 0.5 to 1 kg per cubic meter. So, it is significantly there, it is less than 100 gram. So, it is almost 7 times to 10 times higher. So, it is loading is 7 to 10 times higher than the pop shooting, but the difference is that we do not need any drilling, and the fly rock generation of fly rock is not very significant, as the explosive in the top part and the boulder is in the bottom part of the is the boulder. So, that is why fly rock chances of fly rock is not very high, but the detonation of the explosive on the air medium generates huge noise. So, this is very difficulty. So, let us look into the advantages or disadvantages. No drilling, that is why labor, machine cost, these are saved. Quick and easy, any place, any boulder you can see, you can come with the explosive, you can immediately blast it using the plaster shooting. So, you do not need any arrangement for that, and there is no capital investment required. You need not to have a drill machine, etc. You need not to have a compressor, and noise level is high. Environmental sensitive zone like say where the reserve forests, etc. are there, that may frighten the animals. So, there these things are not used. Utilization of the explosive is a big question here, and the performance is not that much good. So, the explosive requirement is high and the explosive performance is not very good in this particular case. So, that is why plaster shooting is not very well accepted one, but it is easy. So, that is why any place it can be carried out. So, pop shooting and plaster shooting both are popular, and those are used in many places. Generally plaster shooting, the charge has to be placed on a clear surface of the boulder. The contact must be very good with the boulder rock and the explosive, and detonator should be placed such that the directional effect can be utilized for this. We will get this one as we will discuss the shaped charge in the plaster shooting. The shaped charge is one special theory where we provide or we give the charge a shape. Generally what is happened, a copper cone or is inserted in the explosive part, so that the explosive get a shape, like this, while the blasting is carried out. So, this shaped charge can be used in boulder blasting. There is a theory behind this. So, let us look into the theory first. This theory is available in Wikipedia also. Shaped charge is basically a device consists of a solid cylinder of explosive with a metal lined conical hollow in one end and a central detonator or array of detonators. So, basically what is happening here, the explosive energy is released directly away from the normal to the surface of an explosive. So, by shaping this one, what we are doing? We are basically finding that explosive energy in the void is basically concentrating. So, the explosive energy is basically guided to concentrate in that copper cone part, which we saw in the previous figure, that the copper cone part. So, explosive energy is basically guided in this copper cone part, and this generates enormous pressure, and that is why the energy will flow in that direction, and that will generate enormous pressure, and that will create the fragmentation in that particular direction. So, this is basically directing the explosive energy into one way, so that the maximum pressure can be generated. So, if you look into the pressure front, the pressure front as the conical shape is provided here, you can see the pressure front is concentrating here. So, this is the time evolved formation from 0, how the pressure is being built up, say in 400 microsecond. This is showing the enormous pressure build up by using a shaped charge. So, often if we are using a shaped charge in the secondary blasting, that will reduce the requirement of the explosive quantity in a plaster shooting case. Okay. So, that is the benefit we can have. There is another application of this one is also there. This shaped charge can be used for the underground metal mines, chutes or finger races, where because of the blasting, a ring hole blasting we have already discussed, as the ring hole blasting or the long holes are VCR method, long holes are blasted, that are basically generating huge big boulders, because it is a similar type of bench blasting which is having the hole length of 20 meter, 30 meter. So, that is basically generating huge big boulders, uncontrolled boulders, and those boulders are coming down into the finger races or so. So, often these boulders are basically keyed each other in a such a position, so that it stops basically the material flow in this direction, but these big boulders, these large big boulders, these are positioned in such a way, they basically block this portion. So, no further material is coming down at this place. It is very dangerous situation, because you cannot allow someone to stand here and get it clear, because the moment it will he will do something here, it may suddenly collapse and the person may die. So, in this type of situation, it is very difficult condition, you cannot allow anyone to enter in that particular position. So, the whatever blasting or drilling has to be carried out, that has to be carried out from away from this. So, in this type of situation, generally shaped charges are used. So, this is the shaped charge are used here, where the explosive is given a direction, shape direction is given towards this point, and it is detonated. So, the explosive energy is traveling in this direction, and it will hit this boulder, fragment that boulder or disrupt that boulder, and allowing the dislodging of this material or free flowing of this material by removing this blockage. So, this is one good example of use of shaped charge in secondary breakage or secondary blasting, which is very commonly used. Otherwise, you can use the plaster shooting here also, where you can throw the explosive already fitted with a mud. This is the mud clap, and in this mud clap one can keep the explosive like this. This is the detonator. So, this portion is thrown by hand. This portion is thrown by hand from this, someone standing at this place, he can throw this one, so that this stuck on this. This one is stuck at this place, and that can be blasted. But there are likely chances, instead of sticking at this place, this dislodge, but that they can try to do that one. But this shaped charge is a better option over this plaster shooting in this particular type of blasting, where it can be practiced very easily. The next technique is snake holing. Snake holing, I have already told you that snake holing is practiced for in situ boulders, where the boulder is surrounded or impregnated inside the earth crust, and in this case, instead of carrying out a drilling and blasting here, one can carry out a drilling adjacent to that boulder, and after carrying out drilling that one, an explosive can be placed here and accessories are properly placed, then the stemming will be carried out and it is blasted. So, here the explosive is not directly placed on the boulder, but explosive is placed very close to the boulder. So, in the snake holing, actually explosive is placed very close to the boulder, and with this effect the cracks are generated in the boulder and that is blasted. But similar to the plaster shooting, here also our explosive requirement is very high, and that will basically disadvantages you can consider. So, only the benefit part is that at the explosive is in situ condition, the noise generation is not that much high, but the likely chances of fly rock is also there. So, snake holing is basically practiced in case of naturally occurred boulders, not in the mining conditions, where the boulders are fractured and removed by not directly drilling into the boulders. So, this is economical than the plaster shooting, but and less noisy, but disadvantages is that again you have to go for drilling etc., which are not benefits not very beneficial for the mining activities. The fourth one, which is very unique one, that is the boulder blasting using a tying by detonating fuse or detonating cord. Here basically the big boulders, in this case a number of detonating fuse are basically wrapped around the boulder. So, here the boulder, around that boulder a number of turns wrapping of the detonating fuse is carried out. So, you know detonating fuse is basically, or detonating cord is basically a raft of PETN. So, which is having very high VOD of 7000 meter per second. So, this high VOD basically wrapping of this one, this high VOD act as the explosive, and a number of turn basically increase the charge concentration in that. So, by wrapping this one, this is basically giving the detonating pressure in both the directions. So, this part here, this is in the bottom part, here this is in the top part. So, from all around the energy is concentrating at the center part of the boulder, and that is basically creating a damaged surface like this, and this will disintegrate the boulder into two pieces. So far whatever blasting is carried out, there you have seen the boulders are basically fragmented into the number of pieces, but using this particular tying by detonating cord will allow you to disintegrate the boulder in two pieces, that is the piece 1 and piece 2. So, there is no huge fragmentation, and by this way this is absolutely basically avoiding any fly rock conditions. There will be zero flying of the boulder will just break into two pieces and stay in the same place. So, that is the benefit of tying of detonating cord, and this will control the size, this will control the fragmentation of the boulders, but only one very serious drawback is associated here, that is it generates huge noise, because detonating fuse itself 700 VOD and the complete detonation process occurs in the air medium only. So, the huge noise are generated, air overpressure is generated. So, it should not be carried out when anyone is the nearby available or nearby inhabitancy is available. In those conditions this should not be carried out, but this can be easily carried out even where it at a very close proximity to any structures. Only the noise is the problem, but apart from noise nothing else is problem. You do not have any throw, you do not have any shattering effect, nothing is there, only it will disintegrate the rock into two pieces. So, this is very good secondary blasting technique. The number of turns of this DF. So, the number of turn has to be placed on the boulder is depending on the size of the boulders. If the size is very big, we need to give 3-4 turns of the detonating fuse. If it is small, then 2-3 turns may be sufficient enough for fragmenting the rock into two pieces. So, this is the requirement, absolutely no other explosives are required, only detonating fuse and the detonator is sufficient to carry out secondary blasting for this particular conditions. So far we have discussed the boulder blasting techniques, either it is natural boulder or the boulder generated from the primary blasting. These are the breakage process of boulders using blasting. Apart from the blasting, there are two other methods possible, that is using the mechanical means, that is the using the rock breaker, that is the hammering of the boulders, and second one is the by chemical means. So, let us look into this. The first one is that let us first watch this video. So, you can see this is a very slow motion video, only 1.5 minute video, this is available in the YouTube. So, this is a slow motion video which shows you how the hammering process is going on. You can see one by one, it is a pneumatic hammer. There are many pneumatic hammers available of different hammering strength. So, this is a pneumatic hammer, gradually it is hammering, and you can see with the more number of hammering, the boulder is disintegrated into the pieces, and as it is disintegrated, it is also removed. These pneumatically operated hammers can be easily placed within a half an hour in an excavator boom. In an excavator boom, within half an hour, this replacing the bucket, this hammer can be placed very easily, and this method is very easy. The any problems which are associated with the blasting process can be avoided by using this mechanical hammer system, and these hammers are not very costly, depending on the weightage of the that is the hammering strength required. This hammers are easily available. This can be easily mantled and dismantled along with the excavator's boom. So, this is a slow pace one we have seen. This is now in the real time you can see. This is basically nowadays hammer mining has come out, where you can directly carrying out mining using the hammer only, rock breaker only. So, this is first the breaker is basically setting the rock. You can see how the breaker is basically positioning the boulder for its best hammering position. Say it is now placed the boulder which is good for the hammer to. Now, you can see the hammering in real time. The previous video we have seen it is in slow motion, but now we can see the hammering in real time. You can see how fast the hammering is carried out, and you can control the fragmentation size also by placing your hammer in the particular positions. So, this hammering is very easy one, and currently though explosive is very cheaper one, but hammering is currently with the more better technology, the hammering is almost in compatible position with the in costing with the drilling and blasting. So, this is the hammer you can see which can be easily mounted on the excavator boom. So, this video is also available in the YouTube. So, one can see it in the YouTube. Now, this is also again given in Gimeno, where the power required in hammering with respect to the yield. If we need, this is the yield requirement meter cube per hour, which is given here, and this is the power requirement, that is the power of the hammer cap, and this is the rock strength. So, if the rock strength is less than 120 MPa and we deploy a hammer power of 12 kilowatt, then we can expect a 10 to 30 meter cube per hour production from this rock breaker mining. But if the power is 24, we can have a 19 to 60 meter cube per hour production in case of less than 120 MPa. So, this is depending on the rock strength. The possible yield from the three types of hammer are basically given in Gimeno, which is represent here from directly from the Gimeno. Apart from that, the another method which is possible we have discussed using a chemical method. In chemical method, basically expanding cements are used. In expanding cement, first let us see the video, then I will explain that one. So, you can see there is, this is a domestic one, where someone has found a boulder of rock maybe during the foundation digging. So, this boulder has to be blasted. So, what he is doing? He is basically drilling this one. So, this is the drilling is carried out in the boulder. So, there are a number of holes drilled in a line. So, there are 3 holes made in a line, and now in these holes he is basically placing the expanding cement. So, these cements are having the properties, say while these cements are mixed with water and then it is placed in the hole. After that, during the curing, it expands in volume. So, as it expands in volume, if you seal the hole, it tries to increase the pressure laterally along the hole and the rock breaks under that pressure. So, the pressure is gradually build up. So, in blasting basically we use dynamic stress, we go for dynamic stressing of the material, we are giving the dynamic force, but here it is static force is given, static stress is given to the rock and rock fails under that static pressure. So, now these holes are filled with this expanding cement, and now you can see the boulder is, after that curing, the boulder is now broken into the pieces. So, basically basically it is, if the boulder, we have drilled this one, after that we place the expanding cement, and in all the cases this cement must be fully filled, because if there is a gap, the expanding cement will expand in that gap. So, there should not be any gap kept in the hole, it should be completely filled, and the top part of the hole must be plugged. So, there is a plug, tight plug will be placed in the mouth of the hole, and the complete hole must be filled with that expanding cement. Then the expanding cement will try to increase in volume. So, it will give a stress in all directions. So, this plug is tight enough to hold that, withstand that pressure, and this, now this pressure will exert on this. So, if there is a boulder, along that there are 3 holes like this. So, this pressure are basically given on this direction. So, a cracks will generate along this line. So, this is the similar way, here the cracks are generated by this video. You can see there are many such videos are available in the YouTube. So, this is the way the expanding cement works. In fact, in India also SCC Cements manufactured this one. This is called Aconite. So, this is also available, that expanding cement is also available here. So, the benefit is that it can be carried out any place, even after doing this one can stand beside that. There is no danger of safety related to this. There is no generation of noise, no threat to the safety because of the inhabitancy. Any place it can be carried out any time. Only the fact is that this cement is little bit costly, and it takes a long duration for fracturing. It takes almost 6 to 12 hours for generation of cracks in the boulder. So, it takes time for fracturing. So, that is another drawback of the system. Otherwise, this system is very good and applicable to any place, though it is a little bit costly arrangement. So, this is more or less about the boulder blasting. Now, we will discuss one accident case which has been observed, and based on that, Director General of Mine Safety in India has come out with this circular, that is DGMS Technical Circular number 14 of 2020. So, this is happened in one open cast coal mine where 4 persons fatally injured and 3 are seriously injured during a boulder blasting. What happened here? A boulder blasting is carried out with a 150 or 160 mm large dia drilling, and huge quantity of explosives are placed there, and that blasts prematurely there. So, that is basically a wrong design of the boulder blasting, a wrong execution of the boulder blasting, and no way on any engineering and technical community it is supported. So, considering this, there are on post inspection it is found there are many drawbacks. Based on that, Director General of Mine Safety has come out with the decision that the fragmentation of boulders by blasting shall be avoided as much as possible, though it is not possible to avoid in all the cases. A mine may not have a rock breaker because they are not experiencing that one. So, fragmentation by blasting, secondary fragmentation, secondary breakage by blasting may have to be carried out, but as much as it must be avoided, and avoiding will allow you to use of rock breaker or so, but if the blasting secondary blasting has to be carried out, for that a separate small dia drill machine must be kept. Okay. So, large dia hole in the secondary blasting is hereby prohibited, not allowed, and in the small diameter hole small quantity charges, that is the small dia explosives should be blasted if it is a pop shooting is carried out. Otherwise, with a small diameter charges cartridges, plaster shooting can be carried out in the cases, but huge quantity of explosives should not be there. And second condition is given that the simultaneous blasting of charges in benches and the boulders shall not be done. It must be prohibited and proper SOP, SWP must be practiced. So, this is the post blast, after post blast inquiry, Director General of Mine Safety has come out with these suggestions. Basically, these are well understood facts, only the improper engineering, improper blast designing resulted into such accidents. So, boulder blasting is a very delicate one. I do not believe that it can be eliminated, but it must be avoided as much as possible. You must design your primary blast properly, so that the generation of boulder can be avoided as much as possible. If some are coming out, then the secondary blasting can be carried out, or the rock breaker can be used for breaking of those boulders. So, this is also available, this circular, Director General of Mine Safety circular is also available in the website. So, let us complete our boulder blasting, secondary blasting of the boulders lectures here. We will continue with the next topic in the next class. Thank you.